All right, in this problem, it's another roll-off problem. It's a horizontal speed. Um, this one, we've got, it's talking about a roof, but you might as well display it as a table. They're all the same. You have an object that has a certain horizontal speed, dx, leaving the edge, and then it's going to start to fall down. They gave the height of the roof is 9.4 meters. That would be the y variable, so 9.4. And initial horizontal velocity, so they're talking about Vx right here is 7.2 meters per second. So that's going to go here, 7.2 meters per second. And how long does it take to reach the ground? So what they're asking for here is t. Over on the x side, I do not have enough information. I've only got one variable. I need at least two. So I'm going to go to the y side, and vi is going to be 0. It is 9.81. And I have the y variable, so I have 3, so I can solve for t. That's what I want. So I'm going to use the same equation as last one. Y equals 1/2 at squared, rearranged as 2y a square root equals t, which is 9.81. And on top, I've got 2 times 9.4, the square root of that whole thing. And that comes out to 1.4. And that's what my answer was. I rounded it up from 139. So that works out. Let's get rid of that and start on part B. All right, so we filled in t at 1.39, which is also the same as this side. It's the only thing that goes from one side to the other, 1.39. Those are the same. So we have those filled in. And the next question says, what's the final vertical velocity of the ball? So what they're asking for there is VF. They're saying when the ball rolls off the edge, or the shingle in this case, when it hits the ground, the final velocity before it hits the ground, that's a y component because it's vertical. So that's what we're going to solve for over here. The easiest one is VF equals VI plus AT. VI is 0, so it cancels out the problem. VF equals A times T, which equals 9.81 times 1.39. And I get 13.58. So that gives me the velocity at which it strikes the ground when it gets to the bottom. Part C said how far does it, excuse me, how far does it move horizontally? So it's asking for the distance in the x direction. So the sorry, I lost control of my board there for a minute. So this thing is traveling in this direction, and it's going to land at a path here, and they want to know the distance, this x value here, how far did it move in that direction. Well, that's over here on the x side, and since we have Vx equals x over t, this is what we want to solve for, is the x, so we rearrange it to t times Vx equals x, and so that is 1.39 times 7.2, which equals 1.39, 10. So it traveled 10 meters from the from the edge of the table all the way across to where it landed.